I've started the recording. I think. Okay, time to go through this. Okay, here's my formula. I just got it from what Dr. Cortez provided us. I'm gonna use this. So S naught. You normally use 0.39, but not this time. You use 0.4 for S naught. 0.4. Depth, that's what we're trying to solve. PT is normal terminal serviceability. Major highways, which this is, so it'd be 2.5. 2.5. EC, what's that, the elastic modulus of the concrete? Elastic modulus of concrete is 3 million psi. Right? Yes, 3 million psi. Is that 3 million? Yeah. 3e to the 6. S sub C, modulus of rupture at 28 days, which is right here, 450 psi. 450 psi ZR. Normal deviate for a given level of reliability. Normal deviate. So we have 92%, and the normal deviate for 92% reliability. I know I had it. Come on. Oh, here we go. Normal deviate for 92% reliable. Okay. Reliability of 92%. Negative 1.405. Negative 1.405. Negative 1.405. Negative 1.405. CD. Drainage coefficient. Drainage coefficient. I remember seeing there being a poor drainage. Drainage coefficient. Drainage coefficient. Poor drainage. So we have poor drainage. And it gets an average. I think I might need to use my engineering here, but 69 inches of rain a year. Percentage of time pavement structures exposed to moisture levels approaching saturation. I know that 69 inches a year is a lot. I'm going to go with greater than 25%. I would say poor 25, that's 0.8. I'm going to risk it because that's a lot of rain, at least to my New Mexican self. J, what is J? Load transfer coefficient. Okay. Jointed reinforced concrete pavement. Jointed reinforced concrete pavement with an asphalt concrete shoulder. Okay, asphalt. Load transfer device. That's 3.2. I see concrete and I see jointed reinforced concrete pavement with asphalt. Yes, 3.2. I'm going with 3.2 here. My K is 150 PCI. Okay. And what they want here, I'm going to try to use solver. Let's see what happens if I use solver. I'm trying to round up the next 1/4 inch. What am I trying to get? 10 million esals. And this is actually me going out on a limb here. Data solver. Because I could just input. If this doesn't work, I'm going to 6 by changing variable cells that. Let's see what happens. Oh, no. Let's try. Come on, solver. 1. It's 10. 1, 2, 3, 4, 5, 6. Oh. Okay, I think that's my answer. Can I stand by that? 14.19, so that would go, if they want us to round up, 1/4 inch. 14.25. Well, I'm not even halfway done with my time. I can check everything. Let's check everything. Oh, that's kind of weird, huh? Wonder if I can. There, and then here. Ooh. Oh, well. Okay. So my S naught is given right here is 0.4. My concrete modulus of rupture. My SC right here. Where did it go? 450 psi. K is 150 psi. Use 0.4 for that, and then reliability of 92%. That's probably, if I mess up, it'll probably be somewhere around here. Negative 1.405. J, I think, is where I'll mess up if I mess up anywhere. How did I get J? J is load transfer coefficient. Load transfer coefficient. And it is jointed reinforced concrete pavement with asphalt concrete shoulder. I see asphalt. I don't see tied PCC. I'm going to go 3.2. I'm standing by that. Okay. Well, that is more or less 14.25 inches. And that shall be my submission. And I'll even submit it right now. Woo! Got it. Okay. That's the end of my recording.